This case is another important derivation from optical instruments part, the compound microscope. Simple microscope has a limited magnification. It can be adjusted only by adjusting the focal length. Shorter focal length will give you higher magnification or magnifying power. But there's a limit for reducing focal length of a single convex lens. So we're using the property when two lenses are joined, the magnification is the product of magnification of each lens. So using that property, we can make a compound. Compound means more than one lens. Compound microscope. So there are two lenses used. One near the object to be observed called objective lens, and one near the eye of the observer called eyepiece or eye lens. The objects observed using a compound microscope are very small, bacteria, virus, cells like that. So the aperture size of the objective lens need to be only very small. Focal length for large magnifying power should be very small. So objective lens has to be a short focal length and small aperture. Small aperture for small size objects and short focal length for large magnifying power. Objective lens forms slightly magnified image. So the eye lens has to be slightly greater in aperture compared to the objective. Even the focal length has to be short but slightly greater than that of the objective lens. So both aperture and focal length has to be short, but both are slightly greater than that of the objective lens. So first case, the image is formed at near point. So ray diagram. There are different methods. Conventionally, you draw an object, then its image formed by the first lens that acts as the object for the second lens, and that forms the final image. It's sometimes hard to get the final image of both lenses together on a paper. There is another way by which you can guaranteed get the image on the paper. It may not be the conventional way. The steps you can see. Principal axis. Position of first lens. Objective lens. Center of the lens, C1. Normally, first we draw the object, then to the image. Here we fix both the lenses. The second lens has to be slightly greater aperture compared to the first one. So draw principal axis, draw both the lenses, distance, any distance which is adjustable within the paper. Leave some 5 cm on left side, 5 cm on the right side. Center of the second lens is C2. Now we are drawing the image reverse. First, the final image will be drawn. The final image is formed, which is marked as IM. The final image is formed by the second lens, which is the eyepiece or eye lens. The image is virtual and inverted. So this image formation, when you draw one light ray from M to C2 straight. Second light ray from M passing below C2. Now, if you draw a line parallel to the principal axis from this particular point, we'll get the image formed by the objective. This is the image formed by the objective, which acts as the object for the eyepiece and forms the final image. You can see one light ray from, if you mark this as I dash and M dash, this is the intermediate image. From I dash, M dash acting as the object for the eyepiece. One light ray will go parallel, pass through the principal focus. So the parallel light ray passes through the principal focus, eyepiece, so FE. So same distance on the left side also, focal length, FE. You can mark with scale, measuring equal distance on left and right. So the first light ray will go parallel to the principal axis, will pass through the focus. Second light ray goes straight through the optic center without any deviation. Now these light rays are diverging, so you extend back and get the image. So that's what really happens. This is the extended light ray. So I'll repeat the principle. You first draw the principal axis, objective lens, eyepiece with a suitable distance, leaving enough gap on left and right. Then first draw the final image IM behind the objective lens. Now from M, draw one light ray passing through C2 straight. From M itself, draw another light ray passing through a point below C2. That you can take any distance, maybe 2 lines below if you have a ruled sheet. It also goes straight. So where that second light ray intersect the principal section of the lens, from that point draw parallel to the principal axis. Where that light rays meet, that will be the object for the eyepiece, which is the image formed by the objective. Now you can see this is the parallel light ray passing through the focus. This is a focus. Other light ray passing to the optic center without any deviation. Now this will be made dotted line so that to show that this virtual light rays extended back the real light rays. So the same thing will happen from I dash M dash with objective lens. We have drawn M to C2. So here from M dash to C1, one light ray. Then we have drawn M2 below C2. Here above C1 because it's on the top. Then you extend this back like the previous one. So where they meet, that's a actual object. So that's a real object for the microscope. You can see very small. So this is OB. So again, here also the parallel light ray. The parallel light ray is supposed to pass to the focus. So this will be the focus, this point, F of the objective lens. So same distance you can mark by measuring here on the left also, F of the objective lens. So measure with scale and mark both the sides equal distance. The right side you can get where the light ray intersecting the principal axis. Measure with scale the same distance to the left and mark. So now you can see the image formation OB. One light ray parallel pass to the principal focus. Second light ray pass straight through the optic center to form the image. Then that will act as the object and final image is formed at near point. So if you label, this distance will be UO. This distance will be BO. This will act as the object for the eye lens. This will be UE. And this is the final image formed at near point. That will be D. So this is U of the objective lens. This is B of the objective lens. This is U of the eye lens. This is B of the eye lens, which is the near point distance. U for the eye lens. This is the B of the eye lens, which is equal to minus B. So the image formation is important. How to draw the final image. Following this way, away from different from the conventional way, ensure you can adjust the image within the available space. Now this angle will be theta I, because this is the final image. Draw I and M to C2. That angle will be theta I. So C1, C2, the center of the lens, theta I, FE, FO, UO, VO, UE, V all marked. Now, as per the definition, the magnifying power or angular magnification is theta I by theta O. Theta I by theta O. This is approximately tan theta I by tan theta O. So tan theta I you can find from here. So there are two options. This is a small triangle, this is a big triangle. If you take the big triangle, it will be Im by C2I. And tan theta O, when you draw, you take C2 down and draw a straight line till the near point. So this is the near point distance. And transfer the object to the near point. By definition, when theta O is found, the object should be always at the near point. So this is the near point where the image is formed finally. The object is transferred to the near point to find theta O. If you draw here, that will be getting confused. That's why this is just taken C2 here, near point distance I here, and the object is just transferred to this particular point. Now theta O will be, tan theta O will be I B dash by C2I. I B dash by C2I, and tan theta O will be, tan theta I will be Im by C2I. So you get C2I common. When you divide, that get cancelled. So Im by C2I divided by IB dash by C2I. C2I get cancelled, and the OB is same as IB dash. We just transferred OB to IB dash. If we substitute that, C2I will go Im by IB dash become Im by OB. Just multiply numerator and denominator by the height of the intermediate image, I dash M dash. So into I dash M dash by I dash M dash. We just transfer these two, I dash M dash to the left term, Im to the right term. So I dash M dash by OB into Im by I dash M dash. This is for a particular purpose. I dash M dash is the image for the first lens. OB is the object for the first lens called objective, which will be the magnification of the objective. Then the IM is the final image, which is formed by the eyepiece. The object distance for that is I dash M dash. So this will be the magnification of the eyepiece. M will be equal to MO into M. Into I dash and M dash. It was I1 M1. Now magnification for a lens is VO by UO, objective lens. Even I lens also VE by UE. But the eye lens act like a simple microscope and forms the image at near point. We already derived a formula for a simple microscope forming image at near point, 1 plus D by F. Here it's eyepiece, so 1 plus D by F. If you substitute ME and MO in this formula, you get the magnifying power finally. VO by UO into 1 plus D by FT. Minus UO comes because of the sign convention. And that negative sign indicates final image is inverted with respect to the actual object. From this is clear, for increasing the magnifying power, you need FP to be smaller. Even the UO is very close to FO. So if FO is shorter, U also can be shorter. So decreasing the focal length of the objective also can help in increasing the magnifying power. So selecting short focal length objective and eyepiece, the compound microscope can have higher magnifying power. Now the distance between the two lenses, centers of the two lenses, that is VO plus UE.